Hello everyone. Today we will be talking about the speculation of adaptation and evolution of our descendants in the Arctic after 500 generations. Before we begin, I would like to address the general idea of our presentation. First, we will discuss the environment and ecology of the Arctic. Then, we will talk about our starting population model after the indigenous Inuit people, who were once known as Eskimo, and examine if their traits are present in our group members. After that, the characteristics of the population after 500 generations will be discussed. Without further ado, let us begin. The Arctic island is a polar region at the most northern part of the Earth. It is characterized by extreme fluctuation in temperature between summer 0 degrees and winter minus 40 degrees Celsius. Due to the cold weather, most of the ground surfaces in the Arctic is permanently frozen and covered with ice, which is very slippery. There is also a thick ice buried underneath the ground called permafrost. The Arctic also has extremes of solar radiation, especially during the northern hemisphere's winter months. From September to March, it is one of the darkest and coldest places on Earth, whereas during June, it experiences 24 hours of sunshine. Moving on to the ecology, the Arctic consists of taiga and tundra biomes. Species diversity, nutrient availability, precipitation, and average temperatures increase as you move from the tundra to boreal forest. There are limited plants in tundra biomes due to the extreme cold, low precipitation, a limited growing season, which is only between 50 to 90 days, and virtually no sunlight throughout winter. Thus, most animals there must adapt themselves and have to feast on fish or other animals rather than relying solely on plants. The animals that live in the Arctic areas are such as polar bears, moose, wolves, and seals. For our starting population, we will base the characteristics of our descendants with traits from our group members on the indigenous Inuit people. Generally, the Inuit people are shorter, more stout, and have more robust body and smaller ears to decrease the surface areas that leads to less heat loss and less exposure to coldness. In addition, the Inuit people are able to digest a large amount of omega-3 fatty acid without risking cardiac issues since they have adapted to eating high-fat animals such as seals and walruses.
This part of the presentation is going to look at how our founder population is going to evolve to survive better in the Arctic. So before I begin with my part of the presentation, I want to start by briefly talking about the Allen's rule. So this rule is an ecogeographical rule which implies that animals who are adapted to colder climates will generally have shorter limbs and bodily appendages in comparison to the animals who are from warmer climates. This means that people who have originated from colder regions have proportionally shorter legs for their height. And in our founder population, Jolene is the shortest, so her likelihood of survival is much higher in comparison to the other members of the group. The key idea of this rule is that it looks more closely at the relationship between body surface area to volume ratio for the homeothermic regulation. The people who live in colder climates such as the Arctic will need to conserve as much heat as possible. The Allen's rule predicts that people in the Arctic should have evolved comparatively low surface area ratio to minimize the surface area by which they disperse heat, allowing them to retain more heat. So the basic gist of this is that you need to preserve the amount of heat energy produced by your body to stay warmer. Now, there is sufficient evidence available to suggest that Allen's rule is applicable. Now we are going to look at some examples from current human populations. Individuals living at higher altitudes in Peru tend to have shorter limbs in comparison to the population inhabiting the low-lying coastal regions, which have longer limbs. So here we are making a comparison between people living in higher altitudes in comparison to lower altitudes. So high altitude people have shorter limbs in Peru. People who have originated from colder regions have a heavier build for their body, and people who have originated from warmer regions have a lighter build for their body. People in our founder population, such as Methi, have a higher likelihood of survival because of their heavier build. We can also look at another population from the Arctic, which is the population of the Arctic Mongoloid. So in the year 1968, A.T. Steegman, he was a scientist who wanted to investigate the Allen's rule. He wanted to look if the Allen's rule is applicable to understand the structural configuration of the Arctic Mongoloid face. And from their research, what they found was that certain features of their facial configurations does help them survive better. For instance, narrow nasal passages is going to help them better control the amount of air that they're going to take in. So Asya in our founder population has narrow nasal passages. For instance, broader face, relatively larger head, larger jaw, shorter legs are also known to survive better in the colder climates. Such facial structures are also present in other founder populations as well, and we can look at Eskimos or the Aleut Arctic groups. These populations are our inspiration for how our founder population is going to evolve in the next 500 generations as well. The most likely explanation for the application of the Allen's rule is that the temperature can directly affect the growth of cartilage, providing a possible biological explanation for this rule. And that's why we probably feel that people in the Arctic have shorter limbs as well. From this study done by A.T. Steegman, they were able to conclude that the ears are also significantly smaller. And this is very likely to happen because larger ears is going to make you more prone to frostbites, and smaller ears are going to prevent that. And this particular feature is also present in Jolene and Asya from our founder population. Some other characteristic traits from the Mongoloid population that we feel are also present in our population is low nasal root, flat-lying eyelids, thick dark hair, dark eyes, yellowish brown skin, and usually short and stocky build. And these features are present in almost all members of our group. Now, the reason for the eyes is that having smaller slanty eyes, it helps make room for the adipose tissue around the eyeballs and reduces brow ridges, decreasing the size of the airspace inside the brow ridge. And this is known as the frontal sinuses, which are vulnerable to cold. And this means that it's going to help protect your nasal cavity throughout. This also tells us that by having this particular feature, you're going to reduce the surface area for the nose by having nasal bones that are flat against the face and having enlarged cheekbones that project forward, which effectively reduces the external projection of the nose. And this adaptation will likely help reduce frostbite. And Methi from our founder population has a flat nose and small eyes. The hands and feet form powerful thermal regulators in our body. They serve as heat radiators and evaporators in hot environments and even act as thermal insulators in colder environments. Blood flow to extremities of the hands and feet respond rapidly to exposure to colder regions, and they result in vasoconstriction, and this reduces the blood flow. So by regulating the amount of blood flow to our extremities, we are able to preserve the core body heat by reducing peripheral blood flow. And as a consequence, the skin cools and less heat is lost from the body by radiation. However, if the environmental temperature is below the freezing point, prolonged vasoconstriction can also result in dangerous frostbite. Due to this vasoconstriction, the high surface area to volume ratio, the skin temperature in the fingers and toes also tends to rapidly decrease, and this can cause adverse effects in tactile sensitivity and manual dexterity. So people in our population who anyway have a thicker skin in their hands and feet will still be able to retain their overall strength and maintain a good grip. And Methi from our founder population has a thicker skin on his hands and feet. More body hair is also another beneficial trait which is going to protect our founder population to sustain the amount of heat generated by our body. And Simran and Asya from our group are the people who have these traits. And now we're going to move forward to talk about how our founder population is going to evolve after 500 generations.
500 generations will pass, and our traits blend together to create new mutations. The new people will be generally shorter, with a mean height of around 150 centimeters in females and 160 centimeters in males. Their body mass composition will be different to what we have now. They will have a naturally fatter and musclier figure with broad shoulders, wider hips, and thicker thighs, and generally larger joints of like shoulders, ankles, knees, and elbows. The average weight will increase to around 80 kilograms in males and 60 kilograms in females. Hands and feet will be larger and tougher too. However, arms and legs will appear short in proportion to the entire body. What you notice next is the amount of body hair, including eyelashes, which will be noticeably stronger and bushier and more dense. The body will have less sweat glands too, to work with the conservation of heat. Facial features will be different, starting with bigger nostrils and noses, followed by smaller ears and lips to reduce chapping and be less affected by cold winds. Canines will be sharper and bigger and stronger on an average human on an Arctic island, and their necks will be significantly shorter and fatter. But basically, the overall body composition will be much stronger and larger to help survive in the colds. And that will be it for our presentation. Thank you for listening, everybody.